Lever systems allow movement to take place, and the lever systems in our bodies are formed by bones, joints, and muscles. Every lever system has three parts: fulcrum, load, and effort. The fulcrum is the axis around which a lever rotates, and this is often a joint in the body. The load is the force of the thing that you want to move, and the effort is the force that is applied by the user of the lever system. Within the body, the effort is usually a muscle. We can look at throwing a dart as an example. A lever system is used by the body to enable the throwing of a dart. The fulcrum is the elbow joint, as this is the axis where the movement is enabled. The load is the dart itself that is being thrown, and the effort is the tricep muscle, which extends to create the required force. There are three types of lever system, and these are called the first-class lever system, second-class lever system, and third-class lever system. It is important that we understand why a lever system is first, second, or third class, and it is all to do with what is in the middle of the lever system. For a first-class lever system, the fulcrum is in the middle. In a second-class lever system, the load is in the middle. And for a third-class lever system, the effort is in the middle. A way of remembering this is to think FLE, or fly little elf. There are lots of different first-class lever systems, but we only need to know three different examples. You must remember what the load, fulcrum, and effort are for each of these examples. For a tricep dip, the fulcrum is the elbow and the effort is the triceps. The load that is being lifted is the body weight through the center of the hands. We would point to the hands when labeling the load. When nodding the head, the fulcrum is the joint at the top of the neck. The effort comes from the muscle at the bottom of the neck, and the load is the weight of the head through the chin. We would point to the chin when labeling the load. When rowing a boat, the top of the oar acts as the fulcrum, the biceps provide the effort, and the water acts as the load. As we mentioned earlier, for a second-class lever system, the load is in the middle. There is only one example of a second-class lever system that we need to know, and this is a calf raise. During a calf raise, the load is the weight of the body going through the center of the feet. The effort comes from the gastrocnemius muscle, and the fulcrum is the balls of the feet, and this is because you will push up onto the balls of your feet whilst performing a calf raise. Therefore, this is the axis around which we rotate. There are two examples of third-class lever systems that we need to know: a bicep curl and the action of kicking a football. During a third-class lever system, the effort is in the middle. Whilst performing a bicep curl, the elbow acts as the fulcrum, the bicep muscle provides the effort, and the dumbbell or weight being lifted will be the load. When kicking a football, the knee acts as the fulcrum, the effort is provided by the quadricep, and the ball is the load. The examples that we have gone through for each type of lever system are the only examples that you need to know, but this doesn't mean that they can't be applied in a different way. For example, you could get asked about the lever system used while taking off in long jump or high jump. This is essentially a calf raise, so we know that this is a second-class lever system, and we can work out what provides the fulcrum, load, and effort. Other examples could be throwing a dart, which is the same action as a tricep dip, and 10-pin bowling, which is the same action as a bicep curl. Each lever system could also be shown in a diagram that looks a little bit like a seesaw. In these diagrams, a box will show the load, a triangle will show the fulcrum, and an arrow will show the effort. The final part of this topic is about mechanical advantage and mechanical disadvantage. Each lever system either has a mechanical advantage or a mechanical disadvantage. First class and second class lever systems have a mechanical advantage. Third class lever systems have a mechanical disadvantage. So if you take a look at the table below, you can see a mechanical advantage is that a large load can be lifted with relatively little effort due to the effort arm of the lever system being long. So if you think back then, if we look at an example, so the best example to give for this one is rowing a boat. So the weight of the water is very, very large compared to the effort that you're giving and you're able to give. However, rowers can still move that water very easily, the load of the water very easily, and move quite quickly through the water. And that's due to the length of the lever, which is the oar itself. So therefore, a large load, the water, can be lifted with relatively little effort when rowing a boat. And that's the same, it's not as obvious, but it's the same for all first and second class lever systems. The disadvantage that they have, first and second class lever systems, is that it's slower movement and limited flexibility. So if you think about slower movement, again, rowing a boat, it takes longer to perform each stroke than if you were doing something like a bicep curl. Third class lever system, the advantage is its fast movement and a large range of motion. So bicep curl, really fast movement. Mechanical disadvantage is present though. So you cannot lift as heavy load with the same amount of effort, and this is due to the effort arm being short. So again, if we stick with a bicep curl, you can't lift as heavy load with the same amount of effort. So the effort it takes for your biceps to lift a weight is a very big effort to lift quite a small weight in comparisons to different lever systems in your body. It's also important to know how we work out mechanical advantage. So mechanical advantage is effort arm divided by resistance arm, and you're never going to get figures or numbers that you have to use to work out mechanical advantage of a particular lever, but it's an equation that the exam board want you to know. So just remember, mechanical advantage equals effort arm divided by resistance arm.